Lesson 49, writing equations in slope-intercept form. Slope-intercept form of an equation is y equals mx plus b, where m is the slope and b is the y-intercept. This is something that we talked about a lot in course 3, which is your 8th grade math book, and it's going to be something that follows you through your high school math classes because it's very, very important that you know it. So, y equals mx plus b is your slope-intercept form, where m is your slope and b is your y-intercept. So it says determine the slope and y-intercept of each equation. On one like this, they've already written it in slope-intercept form for us. So I would write y equals mx plus b right above it, because I know that m represents my slope, so this 5, which is in front of the x, is my slope, and my intercept, my y-intercept, is a positive 7. So I would say 5 is my slope, and 7, which we can just, if it's a negative, if there's a minus here, I would have to make sure I show that it's negative, but it's not. So 7 is y-intercept. Okay? Which one that looks like intercept. Okay. On this one, it's nowhere near slope-intercept form right now. So what we have to do is we have to get y by itself, because that's what we have in the original form. The original form is y equals mx plus b. Okay, so I want y by itself. So the first thing I'm going to do is I'm going to start moving things away from y to the other side of the equal sign. So I'm going to start by moving this 6x. Notice that the sign in front, we don't see it, which means it's an understood positive. So the opposite of adding would be to subtract. And what I do to one side of the equal sign, I must do to the other side of the equal sign. Okay, that looks like it. There we go. Okay, so I end up with negative 3y plus 3 equals 0 minus 6x. I just have 6x, negative 6x on this side. So I still don't have y by itself. And the next thing that I'm going to move is the next thing that's farthest away is this plus 3. And the opposite of adding 3 is going to be to subtract 3. So I'm going to subtract 3 from both sides of my equal sign. Now this is where we sometimes get confused. I'm going to bring down my negative 3y and my equal sign. But my question to you is negative 6x and negative 3 like terms? Are they like terms? I hope you're thinking no, because this negative 3 does not have an x with it. They are not like terms, so I'm just going to tack them together. And I'm going to look at my original form. I see here that I want my x term to be first, so that's what I'm going to put first down here. So I'm going to put the negative 6x, and then I'm just going to tack on this minus 3. I hope that you see where we got that from. Okay, now I still don't have y by itself because I have negative 3y. I don't want negative 3y, I want y. So what's happening between negative 3 and y is they're being multiplied, so the opposite is to divide. And what I do to one side, I must do to the other side. So I have to divide both sides by negative 3. So my negative 3's will cancel. I'm left with y equals, and this negative 3 goes to both terms, or all terms, on top. So what I have is I have negative 6 over negative 3x minus 3 over a negative 3. Well, negatives here will cancel. So I have y equals 6 divided by 3 is 2. Bring down my x. Negative over negative gives me a positive, and 3 over 3 gives me 1. So I have it in slope-intercept form now. So all I have to do is recognize what is what. Well, slope-intercept, slope comes first, so my slope is 2. It's always the coefficient that goes with x. This is my slope. And this part that's being added at the end is my y-intercept. Okay? Final answer. It says to graph each line using the equation that is in slope-intercept form. So on A, this is in slope-intercept form, but we're not seeing something right now. So I'm going to write my original form up above it, which is y equals mx plus b. And I can see that m is 6. My slope is 6. But I don't see what my y-intercept is. Whenever I don't see it, I can always add an understood plus 0 there, because I'm not going to change the value of anything if I add 0 to it. So I'm going to write that there to help me graph. Because when I graph, I always start with my y-intercept. Okay. And from that, I graph my slope. So I'm going to start with my y-intercept. I'm going to go to 0 on the y-axis. So this is y, and 0 on the y-axis is right here. So that's my first point. My next point I'm going to make by doing my slope. Well, we know that slope, or m, is equal to rise over run. And currently, this isn't set up as a fraction. So how can I make 6 a fraction? I hope you're thinking that by putting it over 1, and understood 1, we know that any coefficient or any constant that is a whole number, we can make a fraction by putting it over that understood 1. So, my rise is 6, so from this point I'm going to go up 6. 1, 2, 3, 4, 5, 6. And I'm going to run 1, and it's positive, so right there. And now I have my line. Now, it should be straighter than that. I'm not very good with my pen here. I'm going to help you get this into slope-intercept form, but then I want you to graph it on your own. So, we're going to work this just like we did with the last one that wasn't already in slope-intercept form for us. We're going to write our form up above so that we have that to look at. And for it to be in slope-intercept form, I know I need y by itself. So I need to start moving things away from y. So I'm going to move this 5x first. It was being added, so the opposite is to subtract. What I do to one side, I must do to the other. So I'm going to bring this stuff over here. I now have 3y plus 9 equals 0 minus 5x just gives me that negative 5x. Next, I'm going to move my 9, so I'm going to subtract 9 from both sides. And this is similar to the last one that we did, because you should be recognizing that negative 5x and negative 9 are not like terms. So I'm going to put my x term first, because that's what comes first in my slope-intercept form, minus 9. I just tack them together. Now, I'm going to continue to get y by itself, and to do that, I have to move this 3. Well, they're being multiplied now, so the opposite would be to divide, and what I do to one side, I must do to the other side. So I'm left with y equals, okay, and remember, we said that we have to take this to each term. So I'm going to rewrite it as negative 5 over 3 x, and then minus 9 over 3. So when I simplify, I have y equals negative 5 over 3x, because this will not reduce, minus, and then 9 over 3 reduces to just 3. So I said a minute ago that when I graph, I always start with my y-intercept. Okay, so on my y-axis, I need to go to negative 3 to start with. So on the y, which is the vertical axis, I'm going to go 1, 2, 3 down, and I'm going to make my first point. Now from there, I graph my slope. My slope, remember we said, is rise over run. And that looks like rise over run. And my rise is a negative 5. So I'm going to go down 5 because it's negative. So 1, 2, 3, 4, 5. And I'm going to run 3. 1, 2, 3. Now the key here is making sure that you do not represent this negative twice. I represented it once by moving down. Okay, I went down 5, right 3. You could also have gone up 5, 1, 2, 3, 4, 5, and then gone a negative 3, which would mean left 3. 1, 2, 3. You can see that, whoops, pretend like that was both hit. You can see that those would fall on the same line. it's very important that you don't show the negative twice, because a negative and a negative gives me a positive. Well, if you turn it into a positive, you're changing the slope. You can only show it one time. I also told you I was going to make you graph that yourself. Clearly, I forgot. Alright, this one, it wants us to write the equation of the graph line in slope-intercept form. So, slope-intercept form, we know, is y equals mx plus b. Well, whenever you're looking at a line, the easiest thing to find is that plus b, because that's my y-intercept. So I'm going to look at the y-axis. Where does it intercept? It hits right here. Well, this value on y is up 1, 2, so it's just going to be a plus 2 here. So this is where I'm currently at. I need to find my m. Now, you can do that a couple of ways, but I'm going to show you by doing it with what we already know. We know that m we can find by taking y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to take these 2 points that they've given me and I'm going to label them that way. x1, y1, x2, y2. This is what we just did the other day. So instead of y2, I'm going to move this over here. Instead of y sub 2, I'm going to put in 3 minus, I'm going to cross that out because I'm done with it, 2 over x sub 2, which is 4, minus x sub 1, which is 0. So when I subtract, I get 1 over 4. So then I just have to plug that in from my m. I have y equals 1/4 x, because m was my slope, which was 1/4, and then my plus 2, because that's where it hit on the y-axis. Final answer. I want for you to do this one on your own. Last example here. The rental for a canoe is a $20 flat fee plus $12 per hour. Write an equation in slope-intercept form to represent this situation and graph it. Okay, so we know that it's a $20 flat fee plus $12 per hour. So just to rent the canoe, it costs us $20. Each additional hour that we have it for, every hour we have it for, is going to cost us $12 for each hour. So you know how to show $12 per hour, because for 1 hour it would cost us $12. For 3 hours it would cost us $36, and so on. We know that we're just multiplying there. So we would call this 12h normally, but since we're going to put it in slope-intercept form, let's look at that form. Instead of h, we're going to be using x. So I'm going to have y equals, my slope here is going to be my 12. 12x, x is going to represent hours, because for every hour I plug in here, that's going to tell me how much it's going to cost for that $12 fee for each hour. This plus b, this is my flat fee. My flat fee was $20. So I have to put plus 20. This is my equation that I wanted. Then it wants us to graph it. Well, when you graph it, it's going to have to go through 20. So we'll put that right here. And then it's going to have to go up $12 every hour from that. So it's going to be a pretty steep slope. Pretend like that might actually be what it is. If you have a graphing calculator, you can actually punch this right into your calculator and it's going to show you the slope. If you make a note in your notes to ask me how to do that in class, I will be happy to do so, because you'll have to do some changing on your window to be able to see it. But if you want to know how to do that, make sure you put it in your notes and I'll be happy to show you that in class tomorrow. That's all I have for you today, so I hope that you've taken good notes and have a good night.